All right, on this video, we're going to look at law of cosines. So on the previous video, or the previous couple videos, we were looking at sines or law of cosines. So this is when we have a triangle with no 90-degree angle present, but we still want to be able to calculate some missing pieces, either a side or an angle. So the law of cosines is used when we're given either all three sides and no angles, or we're given two sides and an included angle. So if I'm given two sides and an included angle, I can't use the law of sines. Remember, the law of sines is three ratios, and I need at least three pieces. And so I'm going to need at least something opposite. So if I were given like C and B and angle A, well, now I have side C, but I don't have angle C. I have side B, but I don't have angle B. I have angle A, but I don't have side A. So I can't use the law of cosine or law of sines there. I have to use something else, which is the law of cosines. So if you notice, there are three different equations. They are very, very similar equations. Okay, so we start off with a squared equals b squared plus c squared. And then you go minus bc. So if you notice, it's the same two here, b squared, c squared. So it's minus 2 times those two pieces, bc. And then it's times the cosine of a. The cosine, the angle of having the cosine taken of it, is always what we start with here. So if I start with side A, I'm going to take the cosine of that angle. Okay. So if I look at the next one, I have b squared, and now it's a squared and c squared, so they just kind of swap places. So now it's negative 2 times ac, because those are the two pieces here. And now we started with side B, so I'm going to take the cosine of angle B. So same thing for the last one. I have side C squared equals a squared plus b squared. So I have a and b, so that's 2 times ab. And then it's the cosine of c because I started with side C. So they're definitely a little bit more to remember, but if you can remember one of them, then you just have to switch the pattern a tiny, tiny bit to go from one to the other. And the way we kind of decide how do I know which one to start with is going to be based on, what information do I have. And you want to be able to fill in all of the pieces except for one. So if you were given all three sides, you could really start with any one of these that you wanted to find any one of the angles, because it really wouldn't matter which one. You have all three sides, so you could fill in all the pieces except for the angle. If you're given an angle and two sides, then you're going to want to start with the one that uses that angle, because that's the information you'll be able to fill in. So let's go ahead and try this out. So here's the problem they give us. Consider a triangle ABC like the one below. Suppose that A equals 69 degrees. So here's our angle A. And side B equals 35 and side C equals 6. So this is exactly kind of what I was talking about. We have side C, B, and we have angle A. So we're given two sides and an angle. Okay. So now it says that it's not drawn to scale. Do not, take out a measure or a protractor and start trying to measure anything. They want you to solve the triangle using law of cosines. You can use law of sines, and sometimes we'll even use the angle sum theorem. So you're really only going to use the law of cosines once, and then you should be able to use the law of sines, which is a little bit easier to use, just a little bit less to do on that one. And then I think we'll end up using the angle sum theorem at the end. So you carry your intermediate computations at least 4 decimal places and round your answer to the nearest tenth. So at least 4 decimal places out. Don't just round it off in the middle of your computations. If there's more than one solution, you click the OR button. I have not come across that quite yet. So I think it's just an option, but I have not come across that actually happening. All right. So we have our 3 choices here. So now I have to decide which one am I going to use. So to find the equation that would have one piece of information missing. So since I have angle A, side B, and side C, so I have angle B and C, I'm only missing side A. I'm going to use that first one, right? That makes the most sense. So let's go ahead and look at that. So I have a squared equals, and it starts off with b squared plus c squared minus 2 times b times c, so you can see b and c here, times the cosine of our angle 69. All right, so now this is where we're going to start simplifying a little bit. So I have a squared equals 35 squared is 1,225. 6 squared is 36. And now I have 2 times 35 times 6 times the cosine of 69. So I just did the numbers first. 2 times 35 times 6. And now I'll multiply by the cosine of 39. And I also added these two together. 1,125 plus 36 is 1,261. I might have said that number wrong out loud right now. And so now I'm going to multiply by the cosine here. So I have this number. So I rounded to 4 decimal places like it told me to. So round at least to 4 decimal places. That's what it says. If you can leave it in your calculator, I would just leave it in your calculator and do no rounding at all. In fact, that's how I did the problem generally. But this should also work. So now I'm going to subtract those two numbers. So I end up with 1,110.4855. And I'm going to take the square root of both sides because I don't want to know what a squared is. I'm going to take the square root, and I get a equals 33.5. So we have our first piece here. I know the length of a. And now I can use this in another piece if I need to. That's perfectly fine. In fact, you can see I'm actually using 33.3 down here because I forgot to animate that correctly. If you notice, the law of sines has just popped up because now I could use the law of cosines again if I wanted to find one of the other two angles because I have angle B or angle C to find. I could very well use the law of cosines again if I wanted to. It's just a more lengthy calculation. So generally, if you can, you move to the law of sines so that we can start figuring out the missing angle a little bit quicker. So I know this angle A is 69 degrees, so I take the sine of 69 over the side A, which is 33.3, we just found that, equals the sine of C. I don't know what angle C is, remember that's what we're looking for, but I do know that side C is 6. So now I would cross multiply. I'd have sine of 69 times 6 equals sine of C times 33.3. So now you can see why I had that divide by 33.3 up there because I'm trying to get that away from the sine of C. So now I have 0.1682 equals sine of C. Now, I did that very quickly because you didn't see all the calculations there. But in your calculator, you'll have to type in, I have to type in 69 first and then click sine. Depending on the calculator, you might have to click sine and it'll open up a parenthesis and let you type in 69 in the parenthesis. You just have to be aware of the type of calculator you're using. So you may have to play with that a little bit just to figure it out. But I have to type in 69 first, then sine, then times 6. I tend to hit equals just to make sure that it has completely multiplied, but usually the multiplication does just go by itself. And then divide by 33.3, and you will get this number, 0.168. Now, from here, in order to find C, what I'm going to have to use is the inverse of sine. And you find this on your calculator by clicking the second button. Now, if you're on a smartphone, then you're actually going to see this pop up. It's going to go sine and -1. If you're just on a regular calculator like one we use in class, then you click the second button and this will be right above the sine button. And that's actually how you get to those features that are right above the button. You click the second button. So if I click second and then sine, the inverse of sine, then I get 9.7 equals C. So it's definitely a much smaller angle, and that does not look like a 9.7 degree angle at all. That's very out of scale, right? All right, our very last piece here, we have one more angle to find. So since I have two angles, I'm going to use the angle sum theorem. Remember, that means that in a triangle, the three interior angles add up to 180 degrees. So I have 180 equals my 69 degree angle plus my 9.7 degree angle, and then angle B, because that's what I'm looking for. And when I add these two together, I get 78.7. And I'm just going to simply subtract 78.7 from both sides to figure out what is left over for my angle B, which is 101.3 degrees. So again, that does not look like a 103.1 degree angle. So do not trust the diagram unless they tell you you can actually measure on the diagram. Never trust the diagram as drawn to scale. So that is using the law of cosines, law of sines, and the triangle angle sum theorem. Whole bunch going on there, but the focus was the law of cosines. So I hope that helped, and I will see you in the next video.